Hello students, today we are going to start a new chapter, acids, bases and salts. Students, before starting this chapter, I would like to introduce some materials which we come across in our day-to-day activities. Students, there are a wide variety of materials having different characteristics exist around us. These materials consist essentially of elements and compounds. In this chapter, we shall study the kinds of compounds that we come across in our day-to-day activities. On the basis of their properties like sour, bitter and salty, compounds are categorized into three groups: acids, bases and salts. Let's begin with acids. The term acid has its origin in the Latin word acidus, meaning sour. In fact, anything that tastes sour contains an acid. For example, lemon juice, tomato, vinegar, etc. all taste sour. Some of the naturally occurring substances that contains acids are given here. You can see. Aqueous solutions of acids are generally sour in taste. Acids turn blue litmus red, conduct electricity and react with bases to form salts and water. Dear students, an acid may be defined in various ways. Here, first we shall study the definition given by Liebig in 1838. According to Liebig, an acid is a compound which contains hydrogen that can be replaced partially or wholly by a metal or a group of elements acting like a metal to produce a salt. Example: sulfuric acid is an acid because of the following reasons. First reason, C. It contains hydrogen atoms in its molecule. Second reason, the two hydrogen atoms present in its molecule can be replaced partially or wholly by a metal like sodium. Sodium is highly reactive metal. It can easily replace hydrogen from its molecule to produce sodium hydrogen sulfate or sodium sulfate. So see, in first case, partially replacement takes place. Why? Because one hydrogen atom is replaced by one sodium atom. As a result, we got sodium hydrogen sulfate. C. In next case, complete replacement of hydrogen takes place. Here, two atoms of hydrogen replaced by two atoms of sodium. As a result, we got sodium sulfate. Here, sodium hydrogen sulfate and sodium sulfate both are salts. Now, the third you may see, the acids dissolves in water to make a solution that turns blue litmus red. The fourth point you may say, it is sour in taste. Fifth, it reacts vigorously with a base to produce a salt. So, these all activities prove that sulfuric acid is an acid. Now, another definition given by Arrhenius. According to Arrhenius, an acid is a substance which in aqueous solution dissociates to produce hydrogen ions H+. Thus, HCl is an acid which in aqueous solution dissociates to give H+ ions. HCl, when it breaks down, H+ and Cl-. But keep it in your mind, it must be aqueous solution. Similarly, H2SO4, when it breaks, give partially, then in that case HSO4 single minus and H+. But in complete dissociation, H2SO4 breaks down into SO4 2 minus and 2H+. Now, classification of acids. We can classify acids in different ways depending upon the elements present in it. Acids may be classified in two ways. See, first one is oxoacid and second one is hydroacid. So first, oxoacid. acids that contain both hydrogen and oxygen are called oxo acids. For example, nitric acid, formula HNO3, sulfuric acid, formula H2SO4, and phosphoric acid, H3PO4. In all cases, hydrogen as well as oxygen are present here. So these are the examples of oxo acids. Next one is hydroacids. Acids that contain hydrogen and other non-metallic element except oxygen are called hydroacids. For example, hydrochloric acid and hydrocyanic acid. Here formula of hydrochloric acid HCl and hydrocyanic acid HCN are the examples of hydroacids. Now acids may also be classified as follows. First one is organic and inorganic acids. Dear students, basically all naturally occurring acids are said to be organic acids. Inorganic acids which are used in laboratories. Example, hydrochloric acid, sulfuric acid, nitric acid. These all acids are also said to be mineral acids. Next, concentrated and dilute acids. Concentrated and dilute acids. Here, concentrated acid means the solution contains much amount of acids is said to be concentrated acid, and the solution which contains a smaller amount of acid is said to be dilute acid. Thus, concentrated and dilute solutions of an acid differ from each other only in the properties of the acid and water in them. Now, how to dilute an acid? So, dilution of an acid. Dilution of a concentrated acid by adding water is highly exothermic process. So, can't try ever. The heat energy is so large that it may turn water into steam instantly, resulting in the splashing of acid and may cause severe acid burns. So it is highly dangerous. So a concentrated acid should never be diluted by adding water to the acid, but we can make it dilute by adding acid gradually to water. In doing so, the small amount of heat produced is safely absorbed by the large volume of water. Now next, strong and weak acids. The strength of an acid is determined by the amount of hydrogen ions that the acid provides when dissolved in water. Some of the acids when dissolved in water get almost completely dissociated to provide hydrogen ions. These are called strong acids. For example, hydrochloric acid, nitric acid and sulfuric acids are strong acids. On the other hand, there are some acids which when dissolved in water are only incompletely dissociated to give hydrogen ions. These are called weak acids. For example, carbonic acid and acetic acids are weak acids. Here, dear students, if we can say that generally mineral acids are strong acid and organic acids are weak acid. But here it is exception. Carbonic acid is a mineral acid, although it is weak acid.